Hello students, all of you welcome to Future Doctor NEET Academy. Today problem solving session for chemistry. Today the topic is, the lesson is chemical bonding and molecular structure. It's very important lesson. Compulsory we will be getting at least 1 or 2 questions in this unit. Okay. Now we are going to see the questions, 7 questions in this session. Okay. Now we can go to the first one. See, the bond order of N2 molecule is option A 1, B 2, C 3, D 4. We have to find out the bond order. Understood? Okay. So before finding the bond order, you must know the molecular orbital diagram. So here, molecular orbital diagram means, so I will write it here. That is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi 2px, which is equal to pi 2py, sigma 2pz. Okay, so this arrangements is suitable for only up to atomic number. The total number of valence electron is 14. Understood? Okay. That bond order of N2 molecule. That's a question. No. Okay. That nitrogen. Atomic number is 7. So there are 7 electrons in nitrogen. But they are asking what? Nitrogen molecule. In nitrogen, 7 electrons are there. In nitrogen molecule, no. So we know that 14 electrons are there. Understood? Okay. In nitrogen, 7 electron, but in nitrogen molecule is what? 14 electrons. Okay. This is a molecular arrangement. See, this is nothing but sigma 1s means bonding molecular orbital, sigma star 1s means anti-bonding molecular orbital. Then again bonding, again anti-bonding. These are all bonding. Then if I put star means that's called what? Anti-bonding. Okay. It will come later. Understood? After that, the orbitals are there. Understood? Now, we have in nitrogen molecule, how many electrons are there? In nitrogen molecule, we have 14 electrons. That 14 electrons only we are going to fill up here. Okay. So here, this is called molecular orbital arrangements. So sigma 1s is the lowest energy. Okay. So when you go from left to right, the energy level increases. Okay. So we know that we studied Alpha principle. Understood? So we should fill up the electrons according to the increasing order of their energy level. Okay. Now we have 14 electrons. Understood? These 14 electrons only we are going to fill up here. Okay. So here, each and every orbitals we should fill up only 2 electrons. Understood? Okay. Now we have 14 electrons. No. So here put 2 here, 2 here, 2, 2. Understood? Okay. Pi 2px and pi 2py both are having same energy. Then only we should give the electrons also equally. So here 1, 2, 4, 6, 8, 10, 12, 14. Understood? So in this way we should fill up so you should know the molecular arrangements. Okay, how the orbitals are arranged. Then only we can be able to solve these sums. Very simple one. What's the question? The bond order of nitrogen molecule. The bond order. Bond order formula is 1/2 NB minus N of A. It's the formula. Understood? Okay. NB means number of electrons in bonding molecular orbital. N of A means number of electrons in anti-bonding molecular orbital. Understood? You know that N of B nothing but number of electrons in bonding molecular orbital. So here, if any star symbol is present means that's called anti-bonding molecular orbital. If there is no star symbol means that's called bonding molecular orbital. Understood? Okay. Here now we have to find out how many electrons in bonding molecular orbital. 2, 4, 6, 8, 10. So there are 10 electrons in bonding molecular orbital. Understood? Okay. So this is, I put star, no, this is called anti-bonding. I put star, no, this is called what? Anti-bonding. In anti-bonding, here 2, in anti-bonding again 2. So 2 plus 2, we have 4. So N of N of A is what? We have 4. Understood? So you substitute here, you get the answer. So 1 by 2. Okay. 10 minus 4. You know that. Okay, you know that. 6. No. 1 by 2 into 6. We get what? 3. Understood? Therefore, the bond order of nitrogen molecule is what? 3. So among these, C is the correct one. The following. Okay. So nitrogen molecule, then only here bond order is 3. No. Then only we are writing N triple bond N. Understood? N triple bond N. Understood? This is somewhat more stable. Okay. So number of bond order increases means stability of the molecules also increases. Okay. Understood? Okay. Are you following? This is the formula. Bond order is equal to 1 by 2 Np minus N of A. Okay. So you must know the molecular orbital arrangements, then only we can able to solve these sums. Understood? Okay. Now see the second one. Simple one. Here another topic. The hybridization of phosphorus in PCl5. That's a question. Okay. What's the hybridization of phosphorus in PCl5? Phosphorus pentachloride. Okay. So here, first of all, we should know the atomic number, and we should know the valence electron. This and all, if you know, means you can easily solve these sums. Understood? So here, if you take phosphorus, atomic number is 15. How to split? 2, 8, 5. So we can split like this, isn't it? This 15 we can split 2, 8, 5. Then in chlorine, 17. How to split? 2, 8, 7. Understood? So here 5 is the valence electron for phosphorus, 7 is the valence electron for chlorine, Okay. Now you should add all the valence electron. Okay. Then we have one method is there. So if you follow this method, we can able to solve this. See here phosphorus, write it here. Phosphorus, only one phosphorus, So 1 into, what is valence electron of phosphorus? 5. So 1 into 5, that 5. Understood? Then chlorine. How many chlorine? We have? We have 5 chlorine. So what? 5 into, understood? Valence electron. Valence electron is what? For valence electron of chlorine is 7. Okay. 7, So 5 into 7, that 35. So total is what? If you add means what? We get 40. So we have one rule is that if the total valence electron is more than 8 means we have to divide by 8. If it is less than 8 or less than 8 means we should divide by 2. Okay, this is a rule. But is here total valence electron is what? Total valence electron. Understood? Okay. Is more than 8. No. Generally we can divide by 8. So 40 by 8. It's a simple one. That answer will be what? Simple one. 5. Okay. 5 means what? What's the meaning for this? 1 s orbital, 3 p orbital, 1 d orbital. Understood? Are you following? 5 means, suppose 4 means what? Only sp3. Suppose 5 means what? 1 s orbital, 3 p orbital, 1 d orbital. So what's the hybridization of phosphorus in PCl5 is what? sp3d. Okay. Understood? So answer is what? C is the correct answer. Are you following? Okay. Simple one. Based on 5, 6 like that. Okay. 4 like that. Okay. From the value only we can decide the hybridization. Understood? Now see the next one. Another one. Based on bond order. So bond order of 1.5 is shown by among this. So last time we found out the bond order. Now the bond order is given. So which molecule having 1.5 bond order we have to find out. Okay. See here, first term we have done, that is up to 40. If the total electron is up to 14 means we have one arrangements. At above 14 means we have another kind of arrangements or small changes in molecular orbital. Okay. So here this is all oxygen. So oxygen O2 plus, O2 minus, O2 2 minus, O2. Okay. Okay. Here which molecule is having 1.5 bond order means here. So first I write it your molecular orbital arrangements. You know that sigma 1s. Okay. Sigma star 1s. Understood? Sigma star means what? Antibonding. Understood? Sigma 2s. Sigma star 2s. antibody, bonding, antibonding. Understood? Then here, sigma 2pz, then pi 2px, pi 2px is equal to, because the two orbitals having equal energy, then only I put is equal to symbol pi 2py. Okay, so these are all, we are writing now bonding, antibonding, bonding, antibonding. These are all bonding. Now we are going to write antibonding for this. So what's antibonding means? Here first we should write this one, pi star 2px, okay, which is equal to pi star 2py, then sigma star. Okay, these arrangements you must know, then only you can be able to solve this sum. Okay. So above, these are all, when you add the electron, it will be more than 14. Then only this kind of arrangements. Understood? Okay. Now I am going to do only for one molecule. Okay. Other molecule you can easily find out. If I teach one molecule means you can be able to find out other one. See, I find it for O2 minus, because O2 minus only I am going to do. Okay. See, in O having what? Or O having 8 electrons. O2 having what? O2 having what? 16 electron. Minus means plus 1. So we have what? Totally 17 electrons. Understood? Okay. O2 we have 16 electrons. O2 minus plus 1. So totally 70 electrons. That 70 electrons only we are going to fill up here. How to fill up means, as usual I told you. Okay. There is in order 2, 4, 6, 8, okay, 10, 12, 14. Understood? Then 14. Then when you come to these two orbital have equal energy. Then only I put is equal to symbol. Okay. Up to we fill up 14 electrons. No. Now we have only remaining 2 electrons. That 2 electrons how to fill up means, don't put it here only. These two orbitals have equal energy. Then only we put what? 1 electrons. Understood? Are you following? These two orbitals having equal energy. Then only I put it 1 electrons. Understood? So this is a way to do. Okay. Then what's the question? The bond order of 1.5. We have to get 1.5. Okay. So what's the formula? Bond order is equal to 1 by 2 NB minus N of A. This is a formula. You know that 1 by 2. NB means, NB means no star symbol, no. 2, 4, 6, 8, 10. So what? NB is what? NB is what? 10. NB is 10. What is N of A? If you have any star symbol, that one we should count up. Okay, see, third one is the bond order of 1.5 is shown by this molecule. Okay, so which molecule having the bond order is 1.5, we have to find out. That's the question. So you have to know, you must know the molecular orbital diagram, molecular arrangements. Okay, so in O2 minus, O2 having 16 electron, minus means plus 1 electron, totally 17 electrons. That 17 electrons only we are filling here. Okay, the formula is 1 by 2 NB minus N of A. NB is, we have 10 electron. N of A means star. Wherever the star symbol is there, that is called N of A. So we have 2 electron, here 1, 2 electron, here 1, here 1. Totally what? 6 electron. Understood? We have 6 electron. Understood? We have 6 electron. Are you following? Okay, now we put it here. Now we put only totally 16 electrons. Yeah, but actually what? We have 17 electrons. Okay, 17 electrons means you have to fill up what? Here what? You must put 2. That's the correct one. Are you following? Now we count all this: 2, 4, 6, 8, 10, 12, 14, 16, 17. Understood? 17 is coming now. Okay. So here, now antibonding what? 2, 4, 6, 7. So totally we have 7 electrons in antibonding. Okay. 7. Understood? Okay. Now put it here. 10 minus 7. Okay. You know that 3 by 2. 3 by 2 means what? 3 by 2. The answer is will be what? 1.5. Okay. So I teach only the answer. Okay. So you have to find out the other answer like that. Okay. So if you find out other molecule, we will not get 1.5. So that molecule is only 1.5. Answer is what? This answer. In this way you have to do. Okay. So for example, O2 minus I did know. O2 plus is what? O2 plus is what? We have O2 is 16. Understood? We have 16. O2 plus means it lost 1 electron. So 16 minus 1, we have what? We have only 15 electrons. Understood? So that 15 electrons we have to arrange. Then we have to find out the bond order. Understood? Okay. Following? Now you can see the next one. See which of the following pairs of ions are isoelectronic and isostructural. Isoelectronic means what? Same number of electron. Isostructural means what? Same shape and all. Okay. Same number of among the two species, which two species having same number of electron and same shape and all. Okay. Same shape means we must know the hybridization. Then only we can able to find out. Somewhat difficult one, but easy one also. But if you know the valence electron, atomic number and all, you can easy to find out. Okay. Now I am going to see the answers only I am going to do. See, I take this ClO3 molecules. Okay. How to do means how to find out, I will explain. Okay. Like this, you can find out other one. You can easy to find out. See, I am taking these two molecules. See, ClO3 minus. See, okay. In Cl means Cl I told you already. This called 17, 2, 8, 7. 7 is the valence electron. Understood? Okay. So here isoelectronic means same number of electrons. So you take the atomic number itself. Yes, sir. Yes, 17. No, 17. One oxygen is what? 8. So 3 oxygen is there. 3 into 8, 24. Minus is there? No. Minus means plus 1. Okay. Minus means plus 1. So total is what? That 25 plus 17, 42. Understood? Here I take this one. SO3. SO3 2 minus. Okay. Sulfur means I told you sulfur is 16. 16. You take the atomic number. Okay. Number of electrons. Okay. Atomic number is equal to atomic number is equal to nothing but what? Number of electrons. So sulfur 16. One oxygen I told you 8. No. So 3 into 8. 24. Minus 2 means plus 2. Minus 2 means plus 2. So if you add all this, we get what? Here also what? 42. Okay. So these two species having same number of electrons. So isoelectronic. Isoelectronic means what? What's the meaning for this? Iso means what? Same electron. That's the meaning for that. Understood? Okay. So these two species having same number of electron. Okay. Next one is isostructural. Isostructural means we have to find out the hybridization. Then only we can decide these two species are isoelectronic as well as isostructural. Then hybridization. How to find hybridization? Here for ClO3. Now we are going to find out hybridization. Understood? For ClO3 minus, no, ClO3 minus. So what? Now you take the valence electron. Cl is what? Cl is valence electron is what? For Cl, no, 1 into valence electron 7. No, so 7. Oxygen, there are 3 oxygen. So 3 into valence electron is what? 2, how to split? 2, 6. So valence electron is 6. So totally what? 18. Minus 1, no. Minus 1 means what? Minus 1 means what? Plus 1. Understood? Plus 1. So if you add all this, you get what? 25 plus 1, 26. Understood? 26. The following? Okay, 26. So here I told you more than 8 means divided by 8. So here 26 by 8. What's the quotient? Quotient 1. We have, how many times? 3 times, no? We have remainder. Remainder is 2, no? That remainder also you can divide by. So remainder we have 2, no? The remainder also you can divide by So we get quotient. This is considered as a quotient 2. Okay. Now we get 1. Understood? So 3 plus 1. Are you following? Total valence electron is 26. 26 divided by 8. Quotient 1. We have quotient is 3. We have remainder. No. That remainder. If you have any remainder, 0, 1 means leave it. If you have any remainder 0, 1 means leave it. But if you have remainder 2, 3, 4 like that means again you have to take it to once again we have processed the other 2 by 2. We get again quotient 2 is what? 1. Add the quotient. Add the two quotients. Okay. 3 plus 1 we have 4. Okay. Okay. So we have 4 no. 3 plus 1 4. 4 means what? sp3 hybridization. Last time we have seen no. Okay. Last time we got P5 we got 5 no. That's called sp3d. But here 4 means sp3 hybridization. Understood? So in ClO3 molecules we have sp3 hybridization. Likewise we have to find out the SO3 molecules. I am taking these two molecules. I am finding for this only. Okay. Other molecule you can find yourself. Understood? Okay. In ClO3 molecules hybridization is what? sp3. Likewise we find out sulfide. How to find out for sulfide? I will do it here. SO3 2 minus. Okay. Okay. See, sulfur, we have only one sulfur. So 1 into, valence electron is what? 16 outright. 16 outright. 2 comma, 8 comma, 6. Okay, 6. This also 6. Then 3 oxygen, no? Oxygen is what? 3 oxygen. So 3 into 6. This also what? 18. 2 minus, no, minus 2. Minus 2 means what? Plus 2. Okay. Minus 2 is there means we have plus 2. Okay. So if you add all this, again 26. We get 26, no? If you add all this, we get what? 26. Understood? So here also 26. The same process going on. Okay. Here also 26, here also 26. So this having, I told you how to find out. This is sp3 hybridization means this also what? We can say this also having what? sp3 hybridization. So ClO3 minus and SO3 2 minus having same kind of hybridization. If same kind of hybridization means both are having same shape. Okay. So this is the answer for this. Okay. So likewise you can find out other one. Okay. So which of the following pairs of ions are isoelectronic? Isoelectronic means these two species having same number of electron. Okay. So 42, 42 I told you. These two species having same kind of hybridization. Then only I am saying isostructural. Understood? So among this answer. Understood? Okay. Now go to the next one. This is also similar sum. Okay. You must know how to find out hybridization. See, xenon F4. Xenon F4. Xenon F4. Understood? Okay. Xenon means helium. Helium, neon, argon, krypton, xenon. Xenon valence electron is, it's a 8. Understood? 8 valence electron. So how many xenon here? Only one, no? So 1 into 8, we have 8. Understood? Fluorine is all the inert gases having not, except helium. Other than helium, we have valence electron is 8. Likewise, all the halogens having valence electron is what? 7. Okay, fluorine, chlorine, bromine, iodine. The valence electron is 7. Okay. How many fluorine? How many fluorine we have? 4 fluorine, isn't it? So 4 into 7, we have what? 20? 28. Understood? So if you add all this, you get what? 30? 36. Okay. I told you more than 8 means you divided by 8. So 36 by 8. What's the quotient? Quotient 1. How many times? 4 times, no? 4 times, no. We have remainder is what? Remainder 1. Remainder 1 is what? We have 4. I told you. If any remainder 0, 1, no, leave it. But the remainder 4, no. So you have to take the remainder, again do the process. Once again by 2. Again, the second time, no. Then I put what? Remainder 2. Sorry, quotient 2 is considered as 2. Remainder 2 is considered as what? No remainder. Okay, I told you, if any remainder means, you should add all this. Okay, no remainder, any of This is a method. Add all the quotients and final remainder. Add all the quotients and final remainder. If any remainder is there, suppose 1 is coming means you should take this one. Add all the quotient and final remainder. That's a rule. Okay. So 4 plus 2 plus 0. What? Answer is 6. No. Okay. 6 means what? 1 s orbital, 3 p orbital, 2 d orbital. You add all this. 1 s orbital, 3 p orbital, 2 d orbital. So what? 6. So what? sp3d2. This is called sp3d2. No. Okay. Understood? This is answer. sp octahedral. This is answer. Okay. Are you following? Okay. Then one more thing here. But this also sp3d2. This also sp3d2. This also sp3d2. But I put tick mark for this. Okay. Is it correct or not? But here octahedral means no lone pair of electrons. But here xenon F4 is I'm saying here, you know the structure. Xenon F4, no, xenon, you know that? Xenon, okay, okay. How many fluorine? 4 fluorine. The 4 fluorine is present here. Understood? 4 fluorine is present here. Okay. Okay, 4 fluorine is present here. So, xenon valence electron is 8. Okay, xenon consumes only 4 valence electron with 4 fluorine. Remaining 4 valence electron. No, that is considered as a lone pair. This is called lone pair. Okay, understood? Understood. So here lone pair of electron is there. Okay. Suppose all the sides we have atoms are plus or minus, that's called octahedral. But not all the sides are atom. Only the 4 sides are atom. Understood? Are you following? All the six corner we have atoms are plus or minus, we can say it's called octahedral. But only the 4 corner only we have atom. Other 2 places we have lone pair. Then it is called what? Square planar. Square planar means what? This is wrong. This is correct. Are you following? Understood? Okay. Because why I am saying means this is also sp3d2. We get the answer is sp3d2. Correct only. This is also sp3d2. But you put the structure, then only we can able to identify. So suppose we can say xenon F6 means that's correct. Okay, understood? Are you following? Okay. All the 6 places we have atoms are present means it is called octahedral. Okay. But only 4 places only atoms, other 2 places no atoms are there. Instead of the atom, here lone pair is present. That's only we can say it's called square planar. Understood? So this is the answer, correct answer. Okay. Non-zero dipole moment is shown by, okay, the dipole moment. Dipole moment means, it's a product of charge into distance. That's called dipole moment. Okay. Non-zero means here we have some dipole moment. We have some dipole moment is there, then it's non-zero. Okay. Suppose for example, I put carbon dioxide. The structure for carbon dioxide. I put like this. Understood? When compared to carbon and oxygen, who is having more electronegativity character? When compared to carbon and oxygen is more electronegativity. So it attracts electron towards itself. In this way, RMR going on. When compared to carbon, oxygen, ox is more electronegativity. You put the RMR. So the RMR in opposite direction, no. So dipole moment is what? 0. The RMR in same direction, your vector quantity, or simply you can remember it's RMR. Okay. Depends on the electronegativity only we can decide. The RMR in opposite direction, no. Okay. So dipole moment is 0. Understood? So in this case, for example, para-dichlorobenzene. Para-dichlorobenzene is what? Okay, here also what? And compared to this, here it pulled that direction, it pulled this direction. Here also what? The dipole moment almost 0. Understood? Carbon tetrachloride also like that, 0. Okay, the arrow mark goes in opposite direction. But in water molecule only, water molecule O in the middle, we have, it's a bell shape. Okay. Okay, here lone pair of electron is present. Understood? Okay. So when compared to element, the lone pair having more tendency to attract electrons. Understood? So the arrow mark we put like that. Okay. Okay, we put an arrow mark in this way. Okay, it attracts electron towards that direction. But then when compared to oxygen and hydrogen, oxygen having more electronegativity character, so it attracts electron towards this way. The atom are going in same direction. No, if it goes in same direction, it has some dipole moment value when compared to that. Okay, if it is opposite direction, dipole moment is 0. But when compared, these are all having value is 0. Okay, it has some value. Okay, then only so non-zero dipole moment is shown by among these what? Which one is correct one? D is the correct one. Understood? It is based on electronegativity. You must know the electronegativity. Then only you can able to identify which one is having dipole moment, which one not having dipole moment. Understood? Okay. Next one. We found out for diatomic molecule bond order, but this is called polyatomic molecule. In polyatomic molecule, how to find out the bond order means here simply I'll write it here. Bond order is equal to number of bond around central atom number of bond around central atom by number of resonance structure. This is one shortcut method. Number of resonance structure. Simple one. In case of polyatomic molecule, we should do like, you must know the structure and all. So if you take carbonate ion, how to put means carbon valency 4. So one place only I put double bond, other place I put single bond. Okay. Total charge is what? Total I put 2 minus. Understood? Common I put fully square bracket, but I put short form. This also we can do. Okay. Then see, that number of bond around central atom. Number of bond around central atom means how many bond? 1, 2, 3, 4. Okay, so 4 bond. Are you following? Number of bond around central atom. Okay, you must know the structure, then only you can do easily. 4. And number of resonance structure. Resonance structure means we can put double bond here in this position, or we can put double bond in this position, or we can put double bond in this position. There are 3 ways are possible. Okay, so that's called resonance structure. You know that. Okay, so we can double bond here means we get one structure. If we put double bond here means here double bond, here single bond. No, so here or we can put double bond here. Okay, so there are 3 ways of writing for this molecule. Then only number of resonance structure is what we can say one. We have 3 possible structure. So 4 by 3 answer approximately 1.3. Okay, so among these what this answer. Are you following? Okay, it's very important lesson. Compulsory will be getting any 1 or 2 questions. Okay, so go through the lessons carefully. Thank you, students.